Hello everyone, this is the first lesson recording for IM2, March 25th, 2021. Starting with some announcements. Next Monday, Tuesday and Wednesday, you are going to follow outreach schedule. That means there is no synchronous class meeting. So on Monday and Tuesday, you're going to have assignments that is given in Canvas. So it's going to be called classwork 329, not 24 on Canvas, so watch out for that and do any catch-up work that you need to do. Okay, remember, you don't want to fall behind. We're starting a new unit, so let's start strong so that you're going to be able to finish the year strong. Forward-looking. For the remainder of the semester, we're going to be spending our time mostly on geometry, and Unit 9 is going to be on 2-dimension polygons and circles, and then Unit 10 will be on 3-dimension surface area and solids. Alright, let's start by thinking about what are polygons. Okay, so looking at the figure 1, 2, 3, 4, 5, 6. What do you think? Which of these figures are polygons? You can tell me in private chat. So to decide whether a shape is a polygon or not, how would you describe what a polygon is? Well, for it to be a polygon, it needs to be formed by straight sides. It cannot have any curved sides, for example, here or here. Okay, so by that, because of those two, 2 and 5 are not polygons. It needs to be closed. Okay, they're all closed shape. They do not have any sides that are open, so they all pass the second test. And the third, they all have to have no holes. So number 3 has holes, so that means this is not a polygon. But 1, 4, and 6 are examples of polygons. How about names of polygon? This is called triangle, quadrilateral, pentagon, hexagon, heptagon, and octagon. So, how do you think polygons are named? Well, they're named based on the number of sides. Looking at all the numbers. Tri, quad, pent, hex, hept, oct. They are all based on the number of sides. What can we measure when it comes to polygon? Well, we can measure angles, and there are 3 different types of angles in a polygon. Say, if you look at this green turquoise figure, okay, what's inside the polygon? We call this interior angle. Okay, what about the other side? Okay, we call that reflex angle. And then there is exterior angle when we extend one of the sides, and the angle that is formed here to the side extended further, that's called exterior angle. So there are 3 different types of angles that are formed on each of the vertex of the polygon. We can also measure the sides of each of the polygons. So we can measure this side, and this side, or all the outside length, and then therefore we can measure the perimeter. Or for some of the shapes, we're going to be able to calculate the area as well. Okay, different ways. But let's focus on angles for now. And we're going to talk about polygon interior angles in particular. So to do that, you're going to be exploring card number 1 to 6 of Desmos. Here we go. Warm up interior angles in triangle. What is the sum of the interior angle in the triangle? Well, what's an interior angle? Interior angles are all the inside angles, so we can add those, so we can change the shape. Okay, and Desmos is going to measure for you. So if I add 25 plus 68 plus 87, what do I get? I should be getting 180. Would it be the same if I change the shape to look like this? 48 plus 60 plus 72. Yeah, that's still 180. So with the triangle, it doesn't really matter what shape it is. The interior angle is always going to add to 180 degrees. Okay, and we just did that. Alright, the experiment with different shapes of quadrilateral. What do the interior angles sum up to? Okay, so here we have 103 plus 73. That's 176. 176 plus 54. That's going to be 230. And 230 plus 130 is going to be 360. So I know that this one adds to 360. Okay, what if I change the shape a little bit? Okay, would that still add to the 360? Well, let's check that on the calculator. That's 123 plus 53 plus 89 plus 95. And again, I get 360. Okay, so it does not matter what the angle, what the shape looks like. It doesn't, no matter what the even quadrilateral that looks like this. If I figure out if this is 142, what is the interior angle? Interior angle is the 360 minus 142. If I add them all up, it's always going to add to 360. Alright, now diagonals are lines inside polygons which connect one vertex to another. From the red vertex, there's only one diagonal. Go ahead and sketch it in. Okay, so I can use my line drawing, and I'm going to go from the red dot. I cannot go to this because that's just a side. I cannot go to this vertex, so the only vertex I can go to is this one. Okay, and that's my diagonal. Okay, what shape does the diagonals break the quadrilaterals into? Well, I have one triangle here and another triangle here. So I actually have formed into two triangles. Two triangles. The diagonals cut the quadrilaterals into two non-overlapping, they are not on top of each other, triangles. How do the two triangles help us show that the interior angle of a quadrilateral sums to 360 degrees? Well, we know that this blue triangle adds to 180. The green triangle adds to 180. Okay, notice that these two angles form the interior angle of the quadrilateral, and these two angles form the interior angle, plus this angle and this angle. That means we're really talking about 180 plus another 180. That's going to be 360. Alright, sketch the in diagonals from the black vertex to break the pentagon. That's pentagon is a five-sided shape into non-overlapping triangle. How many triangles were created? So from black, I'm going to use the line drawing tool again. I am going to draw to one vertex and another vertex. Here we go. So I have created, a pentagon can be divided up into three triangles. Okay, so I created three triangles. Okay, the pentagon can have two diagonal lines which splits the pentagon into three triangles. What do you predict is the sum of the interior angles in a triangle, in a pentagon? Well, I know this is 180, another 180, and another 180. Okay, and that's all the angles together form the interior angles of that pentagon. That means it's going to be 180 times 3. Okay, and that's going to calculate for me to be 540 degrees. And you're going to explain how you got there. Now we are going to move on to card number 7 to 12. Okay, how many triangles makes hexagon? Hexagon has 6 sides. Okay, so how many do you think? Well, I can draw, or maybe you can figure out without even drawing. 1, 2, and 3. So I can form 3 diagonals, which means I can form 1, 2, 3, 4 triangles. I form 4 triangles. Show different split triangles. Okay, so I used the vertex from here. What if I chose the vertex from here? Okay, so maybe I can choose a different vertex such as this. And it's still the same, 1, 2, 3, 4 triangles, right? It's going to be the same. It doesn't matter which vertex you choose, you're only going to be able to split them into 4 non-overlapping triangles. What do you predict is the sum of all interior angles? So that's going to be 180 times 4, right? Because we have 4 triangles, so that's going to be 720 degrees. We added one more side from the hexagon, that's the 6th side, to make septagon, which is the 7th side. Make a prediction how many triangles the septagon can be broken into. Okay, well, do I have to draw it? 1, 2, 3, 4. Okay, I can draw 4 diagonals. That means I'm going to form 5 triangles. So 5 times 180. I can form 5 triangles. And the sum of the interior angle is going to be 5 times 180, which is going to be 900. Okay, so fill in the table with your answers from the previous sides. So for the septagon, I got 900. Okay, number of triangles were 4 triangles. Okay, was it 4 triangles? No, 5 triangles. Okay, and with the number of sides, the number of triangles was 1, so that's going to be 180. Number quadrilateral, we could form 2 triangles, so that's 360. 5-sided pentagon is going to give me 540, and 6-sided, that's hexagon, that's going to give me 720. 180, yeah. And then 900. What about octagon? I can form 6 sides, and therefore that's going to be 1080. Okay, fill in the table with the answers in the previous slides. How does the number of triangles depend on the number of sides? Number of triangles is always 2 less. Oops, this should be 3. And 4. Okay, 2 less than number of sides, right? And how does the sum of the interior angle depend on the number of sides? So number of triangles will be always 2 less than number of sides, and the sum of the interior angles will be however many triangles multiplied by 180. So we can go from the number of sides, subtract 2 from number of sides, and whatever that number is, we can multiply by 180 to get the interior angle. Alright, so now we have hexagon, which has 100 sides. Draw in the diagonals. Just kidding, ain't nobody got that time for that. Use the pattern you discovered to decide how many triangles would be able to create. If you have 100 sides, how many triangles? 100 minus 2, which is 98, right? What is the sum of the interior angles in the hexagon?